solving exponential equations. Our objectives are to solve exponential equations. We have 4 steps to follow in order to solve this type of equations. The first one is to use algebra to isolate the exponential expression. Then we take the logarithm on both sides. Then we apply the power property of logs to simplify the equation, which is right here. And then from there, we need to solve for the variable. For the first example, we need to solve each equation and round solutions to the nearest thousand. We have 5 to the x power equals to 8. Our first step to solve an exponential equation is to use algebra to isolate the exponential expression. If you notice here, the exponential expression, which has a base and the exponent, is already isolated. So let's go to step 2, which is take the log on both sides. So we're going to take the log of 5 to the x and the log of 8. So log of 5 to the x equals log of 8. And then from here, we use the power property of logs to simplify the equation. So this is going to look like this: x times log of 5 equals log of 8. From here, we need to solve for the variable. X is multiplying log of 5, so we divide both sides by log of 5. So we divide both sides by log of 5. This cancels, so x equals to log of 8 over log of 5. Let's check that on the calculator. And that's going to give us 1.292. So this is my final answer. Let's take a look at example B. On example B, we have e to the x power equals to 3.048. The base of this exponential expression is a natural base. The logarithm with the natural base is called the natural logarithm with notation ln of x. So over here, instead of taking the log, we're going to take ln, which is a natural logarithm. So it's going to look like ln and the ln of e to the x equals to ln of 3.048. We apply the power property, so x times ln of e equals the ln of 3.048. Now over here, this is 1. If you check on the calculator, it's going to give you 1. So anytime you see ln of e, that's going to be equal to 1. Since that is 1, we have x equals the ln of 3.048. We check that on the calculator and round to the nearest thousand. So my answer is going to be 1.114. For example C, our exponential expression is already isolated. So we take the log on both sides. So we have log 4 to the x plus 3 equals to log of 15. We apply the power property. So we have x plus 3 times the log of 4 equals log of 15. We solve for a variable, so the first thing we need to do is divide both sides by log of 4. These cancels. So now we have x plus 3 equals log of 15 over log of 4. Now from here, we're going to subtract 3 on both sides. We subtract 3 on both sides. So that's going to leave us with x equals log of 15 over log of 4 minus 3. Let's go ahead and solve this on the calculator. So we have parentheses, fraction, log of 15 over log of 4 minus 3. Round to the nearest thousand, so that's going to be negative 1.047. So this is approximately negative 1.047. Now for example D, we need to isolate our exponential expression. So the first thing we do is divide both sides by 2. Now we have 15 to the negative x equals to 9. Take the log on both sides. So log of 15 to the negative x equals to log of 9. Apply the power property of logs. So this is going to be negative x times the log of 15 equals the log of 9. We divide both sides by log of 15. So we have negative x is approximately, once we do this on the calculator, that's 0.811, but my variable is negative. So from here we divide both sides by negative 1. So x is approximately negative 0.811. For example 2, our exponential expression is isolated. So let's go ahead and take the log on both sides. We apply the power property of logs. So that's going to give me 12t times the log of 5.106 equals the log of 4. And the same thing, we need to solve for t here. So first we're going to divide both sides by log of 5.106. Log of 5.106. This cancels. So we have 12t equals log of 4 over the log of 5.106. And then 12t, 12 and t are multiplying. That means we're going to divide both sides by 12. So we divide both sides by 12. So t equals to log of 4 over log of 5.106 divided by 12. And once we plug in that in our calculator, t is approximately 0.071. For example B, we have 27 to the 2x equals to 9. This one is very similar to example A. So this one, go ahead and try it out. So example B, try it out. Example C, again, we need to isolate our exponential expression. So the 8 is multiplying with this e to the 2x minus 1. So we're going to divide both sides by 8. So that's going to leave us with e to the 2x minus 1 equals to 40 divided by 8 is 5. And then from here, we take the natural log on both sides. So we have ln of e to the 2x minus 1 equals the ln of 5. We apply the power property of logs. 2x minus 1 times ln of e equals ln of 5. And remember, the natural log of e is 1. So we have 2x minus 1 equals ln of 5. We need to solve for x. So we add 1 on both sides. So we have 2x equals ln of 5 plus 1. And then we divide both sides by 2. So we divide both sides by 2. So x equals to the ln of 5 plus 1 over 2. We plug that in the calculator, and that's approximately 1.305. For example D, again, isolate the expression with the exponent. So first, we're going to add 9 on both sides. So plus 9 plus 9. So we have 4 times 3 to the y equals to 19. And then these two are multiplying, so we're going to divide both sides by 4. So that's going to leave us with 3 to the y equals to 19 over 4. From here, we take the log on both sides. So log of 3 to the y equals to log of 19 over 4. We apply the power property of logs. So y times log of 3 equals the log of 19 over 4. Divide both sides by log of 3. So we divide both sides of log of 3. So we have y equals to the log of 19 over 4 over the log of 3. Once we plug in that in the calculator, that's going to be approximately 1.418. This is a 4. On example 3, we need to solve for t in the following finance formulas. So that means that we need to leave these t by itself. We're going to apply the same steps that we were doing in the previous examples. So the first thing is to isolate my expression with the exponent. So here, PV is multiplying this part, so we divide both sides by PV. You will learn the meaning of this on the next section. So this cancels. So I have FB over PV equals to 1 plus R over M to the MT. Now we're going to take the log on both sides. So let's take the log on both sides. So we have a log of FB over PB equals the log of 1 plus R over M to the MT. And then from here, what do? We apply the power property of logs. So the power property of log says we have log of FB over PB equals to MT times the log of 1 plus R over M. What do we do from here? These two are multiplying, so we divide both sides by the log of 1 plus R over M. These cancels. I'm going to go and continue here. So we have log of FB over PV over the log of 1 plus R over M. All these equals to MT. Now we need to solve for T. M and T are multiplying. What's the next step? Divide both sides by M. Right? So we divide both sides by M. So from here, I have that log of FB over PV over the log of 1 plus R over M. All this divided by M equals to T. And that's going to be my final answer. Now for our last example, we have FB equals PV e to the RT. So anytime we see e, we're going to use the natural log. So first, let's isolate that. Divide both sides by PV. So this cancels. So I have FB over PV equals to e to the RT. We take the natural log on both sides. So the natural log of FB over PV equals the natural log of e to the RT. We apply the power property. So RT times ln of E. And remember, ln of E, this is 1. Correct? This is always 1. So from here, I'm going to continue over here. We have ln of FB over PV equals to RT. And we need to solve for T. So we divide both sides by R. So what do we have left? We have ln of FB over PV divided by R equals to T. And that's our final answer.